Alright, so let's take a look at this implicit differentiation example. So for number 1 here, it says if x squared y plus 2y equals 6x, find dy dx. Okay, so with the implicit differentiation here, basically whenever you take the derivative of a y term, you're just going to attach a dy dx to the end of it. So first we have the product rule. So product rule says we do the first, which would be x squared, times the derivative of the second. Well, the derivative of y is just 1. And then so we just have to attach our dy dx. So the product rule says do first times derivative of second, plus now we do the second y times the derivative of the first. Well, derivative of x squared is just 2x. Okay, plus derivative of 2y now. So the derivative of 2y is just 2, but since it had a y involved with it, we have to attach dy dx. Equals derivative of 6x is just 6. Okay, so now let's go ahead and rewrite this. This is x squared dy dx plus 2xy plus 2 dy dx equals 6. Okay, next thing you want to do is go ahead and isolate your dy dx's by keeping them on one side and bringing everything else to the other side. So I'm going to subtract over this 2xy from both sides so that we're left with x squared dy dx plus 2 dy dx equals 6 minus 2xy. Alright, next here, since we have dy dx and there's multiple of them on one side, we want to go ahead and factor out that dy dx to try to isolate it. So we take dy dx times x squared plus 2 equals 6 minus 2xy. And then the very last step here, since dy dx times x squared plus 2, we could simply just divide by x squared plus 2 on both sides. And there we go. So we're left with dy dx equals 6 minus 2xy all over x squared plus 2. And that would be our final answer. And that's it.